Assalamu alaikum dear students. I hope that everyone is doing well. We have to continue with the same unit, basic statistics, and for today the topic is measures of dispersion. Let's have the introduction of the topic here. If everything were the same, we would have no need of statistics, but people's heights, ages, etc. do vary. We often need to measure the extent to which scores in a dataset differ from each other. Such a measure is called the dispersion of a distribution. In simple words, we can say that measures of dispersion show the variation in a data set, that how the values are dispersed, how the values or the observations are spread out in a data set. In the previous classes, we learned about the measures of central tendency. That measures of central tendency are the techniques by which we can calculate a specific value around which the majority of observations tend to concentrate. But the central tendency measures do not reveal the variations present in a data. For knowing the variations or dispersion, we have to calculate measures of dispersion. So dispersion can be defined as the scatterness of data series, or it can be defined as the extent to which values in a distribution differ from the average of the distribution. We can better understand measures of dispersion by some more explanation. Statistically, dispersion means the spread or scatterness of observations in a data set. The spread or scatterness in a data set can be seen in two ways. The first way is the spread between two extreme observations in a data set. For instance, if I have two data sets related to the marks of the students, in first data sets the highest marks is 100, whereas the lowest marks is 0. So the extreme, or the means we can say that extreme between these observation, the difference between these extreme observations will be 100 minus 0, 100. Whereas in the second data set, if the highest marks is 100, whereas the lowest marks is 40, so 100 minus 40 will give 60. So there the difference between the extreme observations will be 60. So we can say that in first data set the values or the observations are more dispersed, or in the first data set the dispersion is greater as compared to the second data set. The second way is the spread of observations around an average, say their arithmetic mean. Sometimes we are interested to know the dispersion or the deviation from the mean, from the average value. Suppose the deviation from the marks from the average value, the dispersion or the variation of the someone's weight from the average weight can be known as spread of observations around an average. So we can say that the purpose of finding dispersion is to study the behavior of each unit of population around the average value. Population here means the values under study or the data under study. This also helps in comparing two sets of data in more detail. The measures that are used to determine the degrees or extent of variation in a data set are called measures of dispersion. Some important measures of dispersion are range, variance, standard deviation. Before proceeding towards the explanation of these measures of dispersion, let's understand the measures of dispersion in general with an example here. Suppose we have here the marks of students for each different sections of 10th class, 10th A, 10th B and 10th C. Here we have the marks of 5 students, which are 1, 4, 10, 0 and 35, and marks of the students in 10th B in 8, 9, 10, 11 and 12, and marks of students in 10th C are 10, 10, 10 and 10. So here now if we calculate first the arithmetic mean, the average, so the average of these marks can be obtained by adding all these values, then divided by the number of observations. So let's add the values first. 10 plus 1 11, 11 plus 4 14, 14 plus 11 plus 4 15, 15 plus 5 20 and 20 plus 5 30 will be 15. So 50 when divided by 5, because 5 marks or 5 marks of students are given here, so we will get the average as 10. Similarly, if we calculate the average for the marks of section B, so 10 plus 9 19, 19 plus 1 it will be 20, the 20 plus 10 it will be 30, 38, then it will be 50 plus 12. When 50 will be divided by 5, we will get 10, and here 10 plus 10 plus 10 plus 10 will get 50, 50 divided by 5 will get 10. So here the average is same for all the sections. So now means here we cannot have a better comparison by arithmetic mean. So in order to compare the two data sets in more detail, we can calculate the measures of dispersion. So if we choose the first way of calculating measure of dispersion, which is the spread between two extreme observations in a data set. So here we have the extreme observations 35 and 0. 35 is the highest and 0 is the lowest. So we'll get 35. Here the highest value is 12 and the lowest value is 8. So we'll get 4. Here all the values are same, so there is no dispersion. The dispersion or the variation here can be is 0. So now if we can say, if you want to know the extent of variation in these both sections, so we can say that the values or the marks are more dispersed in 10th A, or we can say that in 10th A the dispersion of marks is greater than 10th B. So this is the concept of variation. Now let's have the further explanation of the range in the measure of dispersion known as range. Range measures the extent of variation between two extreme observations of a data set. It is given by formula. Range is equal to x maximum. X is the observation, means maximum observation, and minimum observation. Minimum observation should be subtracted from the maximum observation. So here we can see that for finding range, we have to find the highest and lowest values. 8 is the highest value, whereas 2 is the lowest value. Then we have to subtract the lowest value from the highest. 8 minus 2 will get 6, so the range here is 6. We have another example of calculating range here, that 9 is the maximum value, whereas 3 is the minimum value, so 9 minus 3 is equal to 6. We have another measure of dispersion here known as variance. Variance is a measure of dispersion. It measures how spread out the data is from the mean. If we are interested to know the dispersion of observations from the mean, from the average value, so we can calculate variance. It is defined as the mean of the squared deviations of observations from their arithmetic mean. Let's better understand this with the help of the formula, or with the help of these symbols, which can be used for the calculation of variance. It is defined as the mean. The word mean is used here. It means average. So average means sum of the observations divided by the number of observations. So here sum is used and n is used. So therefore the word mean is used. The squared deviations of observations. Deviation in statistics means the difference of value, any value, or the difference of observations from a fixed value. So here the fixed value is the arithmetic mean, the average, and we have to the difference of it from the observations given in the data set is known as deviation. Mean of the squared deviations of observations from their arithmetic mean means the deviation or the difference of every observation from their arithmetic mean from the average, then it should be squared. Why we have to write the squared here? So that by subtraction we will get some values negative. In order to make it positive or make them positive, we will take the square of those, which will further it will be further explained again. Here we have standard deviation, another measure of dispersion. Standard deviation is basically the square root of variance. It's similar to variance. In variance, in order to make the values positive, we take the square. So now in order to have the standard dispersion or standard variation, what we have to take, we have to eliminate this square. So it can be eliminated by taking square root. So standard deviation is the square root of the variance. Here now there will be no square and there will be square root then. It is also a measure of dispersion, which shows how the data is spread out from the mean. Let's better understand the measures of dispersion by the help of this video.
Practically nobody calculates the standard deviation by hand, as there are tons of applications that do it for you. However, it's crucial to understand what exactly this term means and, why we care about it. To understand what the standard deviation tells us, think about a huge room in which 1. On the left side, there are all of the male members of your family: father, grandfathers, cousins, and so on. 2. On the right side, there are all of the female members of your family. For each side, we'll only measure one thing: the average length of their hair. If you have a, let's say, standard Western family, a quick unscientific look will probably reveal that most men have short hair, whereas when it comes to the women, there's a lot of variation, from very short to very long hair. A statistics enthusiast will quickly tell you that the male group has a low standard deviation. In other words, that more of the guys have hair lengths close to the average than with the female group. Next, we'll get scientific by 1, calculating the average hair size for the male as well as female group. In other words, the mean. 2, subtracting the mean from each individual value, then multiplying the result by itself. In other words, squaring it. 3, we once again calculate the mean, but this time the mean for the previously calculated square differences, and that mean is called the variance. Please note that we divide the sum by the total number of values if the people in question represent the entire group, or if only a sample is picked randomly, we divide by the number of values minus 1. 4, we calculate the square root of that variance, and there we have it. That's the standard deviation. The bottom line is this: whether you choose to calculate the standard deviation or not, the most important thing is realizing that its role is helping you better understand the nature of your data by knowing how close to the average individual values tend to be.
We can better understand the dispersion or standard deviation from this example. That let's have here the example related to the male members of family to one side and the female members of the family to one side. And if you are interested to measure the length of their hair, so we will find that majority of the male members will be of the same will be of the short hair, whereas if we talk about the female members of the family, so there will be much variation from low short hair to long hair, then again long hair and short hair. So we can say that there will be low variation or low standard deviation. However, here will be high variation and high standard of variation in a measurement of hair of female members of family. So here we can say that male group definitely has a lower standard deviation, whereas when it comes to women, so there will be much variation. Let's better understand the computation of the standard deviation.
How to calculate standard deviation. How many vegetables do you have in your fridge? Is that a common amount, or are you an outlier? You can use standard deviation to know whether someone's behavior is normal or extraordinary. Standard deviation, often calculated along with the mean of a data set, tells us how spread out the data is. It is used for data that is normally distributed and can be easily calculated using a graphing calculator or spreadsheet software, but it can also be calculated with a few math operations. We're going to use an example involving the number of vegetables 5 of our friends have in their fridges. They have 2, 3, 4, 7, and 9 vegetables. To calculate the standard deviation, the first step is to calculate the mean of the data set, denoted by x with a line over it, also called x bar. In this case, the mean would be 2 plus 3 plus 4 plus 7 plus 9 divided by 5, which equals 5. Our average friend has 5 vegetables in their fridge. The second step is to subtract the mean from each data point to find the differences. It's helpful to use a table like this. 2 minus 5 equals negative 3, 3 minus 5 equals negative 2, 4 minus 5 equals negative 1, 7 minus 5 equals 2, and 9 minus 5 equals 4. The third step is to square each difference. This makes all the differences positive so they don't cancel each other out. And it also magnifies larger differences and minimizes smaller differences.
Negative 3 squared equals 9, negative 2 squared equals 4, negative 1 squared equals 1, 2 squared equals 4, and 4 squared equals 16. The fourth step is to calculate the mean of the squared differences. 9 plus 4 plus 1 plus 4 plus 16 divided by 5 equals 6.8. The final step is to take the square root. This counteracts the squaring we did earlier and allows the standard deviation to be expressed in the original units. The square root of 6.8 is about 2.6, and that's the standard deviation. We're done. The mean number of vegetables is 5 with a standard deviation of 2.6 veggies. Knowing that about 2/3 of the data...
Here we have exercise 6.3, question number 4. The salaries of 5 teachers in rupees are as follows. And here the data set is about the salaries of the teachers, and we are supposed to calculate range and standard deviation. So the first part is to calculate range. Here x represents all the observations. So for range we have to find the maximum and the minimum observations, I mean the extremes observations. So here the maximum observation is 15,000, whereas the minimum observation is 11,500. So the difference means of minimum observation from the maximum observation is 3,500. So the variation in the salaries of the teacher here is 3,500. The second part of the question is to calculate the standard deviation. Here is the formula for calculating the standard deviation, as it is the as it is the square root of the variance, and here we have the summation x minus x bar whole square n. Here we have to since the standard deviation is used to know the dispersion of observations from the mean value, so therefore we have first of all to calculate the mean, means the average denoted by x bar. Then means the deviation should be found. It means that mean should be subtracted from the every observation given here. Then we have to find the average, their mean, in order to represent this means by a single value. So here let's first of all calculate mean. Summation x divided by n, it means all the observations should be added up, then it should be divided by 5 as the number of observations are here 5. So we'll get the mean is 13,640. Now we have to make the table for standard deviation, and it's ungrouped data because the frequency is not given. So first in first column we have to write all the observations x denoted by x, and the next, now according to the formula, we have to subtract mean from each of the observation. So mean is 13,640 when it is subtracted from 11,500, so we'll get minus 2,140. When now again when the mean is subtracted from the next value, so we'll get 12,040. Sorry, it is 1,240. When 13,640 is subtracted from the 15,000, we will get 1,360, and we have to continue the process till the last observation is done. Now we can see here that some values are negative. So sometimes it happens that some values will be positive here and some values will be negative, so they will cancel each other and we may get 0. So in order to overcome that problem, we have to take the square root in order to make the, sorry, not the square root, the square, in order to make all the values positive. So when the square of this will be taken, means minus 2140 should be squared, so we'll get this value, and all of these should be squared. So at the end we'll get the sum of x minus x bar whole square. There the sum is written. Now we will put the sum in the formula in order to have the value of standard deviation. Here we have n5. N is the numbers of or the number of observations. So here the value is written and here it is divided by 5. So we will get the standard deviation as 1,417.88. Here we have question number 5, B part. The A part is same as question number 4, where you are supposed to calculate standard deviation, so that is left for your homework. Now we have to calculate variance for the data. It's also ungrouped data because frequency is not given. So here is the formula for variance. Is here there will be no square root, it will be with square. So we have to compute variance, and it will be computed in the very same way. These all observations will be denoted by x, so will be written here. Now we are going to find the arithmetic mean, because we have to find the deviation. We have to subtract each means we have to subtract mean from each of the observations, as we are going to find the dispersion of observations from the mean. So let's first of all find the mean. Mean can be found by x, sum of all the observations divided by n. Sum of the all observations will be 75 when we will add up all these observations. When it will be divided by 10, so we'll get 7.5. Now x bar should be subtracted from each of the observations. It is what 7.5. When 7.5 is subtracted from 10, we will get 10.5. When 7.5 is subtracted from 8, we will get 0.5. When 7.5 is subtracted from 9, we will get 1.5, and so on. Now we can see that some values are with negative and some values are with positive signs, so they may cancel out each other, and we may get as some 0. So in order to avoid this, we will take the square of these all. So after taking the square 2.5, the square of this will be 6.25. 0.5, the square root of it will be 25, and so on. You have to continue the same process till the end. Now we have to find the sum of all these. It will be 68.5. When we will put this in the formula, instead of this we will write 68.5, and n is the number of observations, which is 10. If we will count it, 1 2 3 4 5 6 7 8 9 10, so we have 10 values here. So the variance here will be 6.85. Here we are done with question number 4 and 5 of exercise 6.3. You have to do this in the homework. Now for the support, you can watch the video. This is all for today. Have a nice day and stay blessed. One thing more, here is your assessment. You have to compute mean, median, and mode. The following frequency distribution shows the marks of the students. So you have to calculate mean, median, and mode for this. Okay, have a nice day. Allah Hafiz and stay blessed.